The bright blue screen flashed with red symbols in an alien language as Victor Owens stared at the complex quantum equation, knowing that the next 20 minutes would determine his fate at the Galactic Exchange Academy. The final exam for advanced interstellar engineering loomed before him, and Professor Zexillian had made it perfectly clear that no human had ever passed. Your species lacks the mental capacity to solve the pulsarian paradox, Professor Zexillian announced to the class, his four eyes blinking out of sync as he paced the front of the lecture hall. But our educational protocols require that I offer the test to all students regardless of their biological limitations. Victor felt the stares of 32 alien students, each from civilizations thousands of years more advanced than Earth. He was the only human in the entire academy, admitted as part of a diplomatic gesture 3 years after Earth had made first contact. Many considered it a waste of a coveted spot. You have exactly 1 galactic hour to complete the exam, Professor Zexillian continued, his greenish skin glistening under the artificial lights. Any use of unauthorized computational devices will result in immediate failure and possible expulsion. Victor nodded, adjusting his position in the specially designed chair that accommodated his human frame. The Galactic Exchange Academy had been retrofitted to accommodate various species, but humans remained a novelty. 3 years of study had earned him grudging acceptance from most of his peers, but Professor Zexillian remained skeptical of human intelligence. The pulsarian paradox requires you to stabilize a theoretical quantum engine during a subspace fracture event, Zexillian explained. Your solutions must account for all 17 dimensions of space-time relevant to faster-than-light travel. Victor examined the diagram on his screen. The test wasn't just theoretical, it was a simulation of an actual engine design, and his proposed solution would be run through the Academy's quantum computers to determine if it would work in reality. Next to Victor, Krellner, a crystalline being from the Andromeda Galaxy, manipulated his display with practiced precision. The Vraxians were known for their engineering prowess, and Krellner had been particularly helpful to Victor throughout the semester. Beginning now, Professor Zexillian announced, and the screens in front of each student lit up with full technical specifications. Victor's heart sank as he absorbed the complexity of the problem. The simulation showed a quantum engine in the process of catastrophic failure. Subspace was fracturing around it, threatening to tear the theoretical ship apart. He needed to find a way to stabilize the engine and repair the fracture simultaneously. Remember, Zexillian added, floating closer to Victor's station, this test measures your ability to innovate solutions within the constraints of universal physical laws. Some problems simply have no solution for certain species. Victor felt the professor's statement was aimed directly at him. For 3 years, he had fought against the perception that humans were intellectually inferior. Earth was new to the galactic community, and humanity was still proving its worth. 50 minutes into the test, Victor was sweating. He had tried 7 different approaches, and each one had failed spectacularly in the simulation. The problem seemed genuinely impossible. The forces involved in the subspace fracture were too powerful to be contained by any conventional means. Looking around, he saw several of his alien classmates making progress. Krellner appeared to be nearly finished, his crystalline appendages moving with confidence across his interface. Victor stared at his screen, frustration mounting. Then something caught his eye: a small inconsistency in the simulation parameters. The quantum harmonics of the engine weren't perfectly aligned with the subspace field. It was subtle, but it reminded him of something. Back on Earth, before being selected for the exchange program, Victor had worked as a maintenance engineer on the first human-alien joint project, a small orbital research station. The alien engineers had been baffled when one of their advanced communication arrays failed due to what they considered a trivial power fluctuation. While they debated complex solutions, Victor had simply taken a roll of high-density insulation tape, essentially advanced duct tape, and secured a loose power coupling. The memory sparked an idea so absurd that Victor almost dismissed it. But with time running out and no other options, he began inputting a new solution. Instead of trying to prevent the subspace fracture or contain it with energy fields as most of his classmates were attempting, Victor designed a simple mechanical bypass. In essence, his solution would physically bind the fracturing components together while redirecting the quantum energy flow through an improvised pathway. In engineering terms, it was the equivalent of using duct tape to hold a failing warp drive together. Victor's fingers flew across the interface as he refined his solution. It wasn't elegant in fact. It was embarrassingly crude compared to the sophisticated approaches his alien peers were taking, but according to his calculations, it might actually work. With 5 minutes remaining, Victor submitted his solution to the simulator. The screen processed his input, complex equations scrolling faster than he could read. Professor Zexilian moved to stand behind him, all four eyes widening as he observed Victor's unorthodox approach. "What is this?" Zexilian asked, his tone somewhere between bewilderment and disdain. "You're proposing a physical stabilization method for a quantum fracture?" "Yes, Professor," Victor replied, trying to keep his voice steady. "The simulation parameters allow for a temporary physical bypass that can hold the system together long enough for the quantum harmonics to realign naturally." "Impossible," Zexilian stated flatly. "A quantum fracture exists partially outside normal spacetime. You cannot simply bind it together like a broken component." The simulation completed its analysis, and the screen flashed green. Solution viable. Fracture containment successful. Engine functionality restored to 94.3%. The classroom fell silent. Krellner turned his crystalline body toward Victor, the equivalent of his species' expression of surprise evident in the way light refracted through his form. Professor Zexilian's 4 eyes blinked rapidly in succession. "This cannot be correct," he muttered, tapping commands into Victor's console to review the simulation parameters. "You've discovered some error in the programming." "No error detected." The system responded in its neutral tone. "Solution utilizes standard-approved quantum mechanics principles within acceptable parameters." "But this solution is..." Zexilian seemed at a loss for words. "Inelegant," Victor offered. "On Earth, we sometimes say that if it looks stupid but works, it isn't stupid." "I was going to say primitive," Zexilian replied. But there was a new note in his voice, something approaching respect, or at least reconsideration. Yet effective, apparently. As the exam period ended, the other students gathered around Victor's station, curious about the human's unexpected success. Krellner's crystalline form shimmered with interest. "You used physical stabilization as a foundation for quantum realignment," Krellner observed, his voice a melodic hum. "None of us considered that approach because it contradicts established doctrine." "Sometimes the best solutions come from outside established doctrine," Victor said. "In human engineering history, some of our greatest innovations came from desperate situations with limited resources." Professor Zexilian examined the simulation results more carefully. "Your solution would only work temporarily," he noted. "The physical binding would deteriorate within approximately 8 standard hours. That's enough time to reach a repair facility or implement a permanent fix," Victor pointed out. "It's not about solving the problem forever, it's about surviving the immediate crisis." Zexilian's expression was unreadable to human eyes, but his posture shifted. "Perhaps," he said slowly, "I have been hasty in my assessment of human problem-solving capabilities." That afternoon, after the exam results were officially processed, Victor received a notification on his personal device. He had passed, not just passed, but achieved the 3rd highest score in the class. Only Krellner and a sentient gas cloud named Luminera had scored higher, and they both had centuries of accumulated knowledge from their long-lived species. Professor Zexilian requested to see Victor in his office after classes. With some trepidation, Victor made his way through the winding corridors of the Academy's engineering department. "Enter," Zexilian's voice called when Victor knocked on the door. The professor's office was filled with holographic displays showing complex engineering simulations. On one wall hung various certificates and recognitions from across the galaxy. Victor noticed a small Earth plant on the windowsill, a gesture toward diplomatic courtesy, he assumed. "Cadet Owens," Zexilian began, using Victor's formal title. "I have reviewed your exam solution in detail." "And?" Victor asked, trying not to sound defensive. "And I owe you an apology," Zexilian said, the words clearly difficult for him. "I had dismissed human engineering approaches as primitive and limited." Today you demonstrated that different perspectives can yield unexpected solutions. Victor was stunned. In 3 years at the Academy, he had never heard Zexillian apologize to anyone. "Thank you, Professor," he managed to say. "I have submitted your solution to the Galactic Engineering Council," Zexillian continued. "While your approach would never be used as a primary design feature, they agree it has merit as an emergency procedure. They have approved it for inclusion in the Emergency Protocols database." Victor felt a surge of pride. Having a human solution recognized by the Galactic Engineering Council was unprecedented. "There is more," Zexillian said, gesturing to a holographic display. "The Council was intrigued by your mention of this duct tape concept. They have requested detailed specifications." Victor couldn't help but laugh. Duct tape is just adhesive tape reinforced with fabric. It's been used by humans for simple repairs for over a century. We joke that you can fix anything with it. Humor aside, the physical principles you applied have broader applications than I initially recognized, Zexillian admitted. The Council has approved a research grant to explore similar approaches for emergency situations. Victor left the meeting in a daze. What had started as a desperate exam solution had turned into a potential breakthrough in emergency engineering protocols. More importantly, it had begun to shift perceptions about human capabilities. In the following weeks, Victor found himself suddenly in demand among his alien classmates. They were curious about human improvisation techniques and the concept of working with limited resources, something many advanced civilizations had forgotten as their technology progressed. Krellner approached Victor in the Academy's communal area, his crystalline form gleaming. "Your solution has caused quite a stir among the faculty," he said. "Professor Zexillian has been defending your approach in departmental meetings." "Defending it?" Victor asked, surprised. "Yes. Some faculty members consider it a fluke or a quirk of the simulation. Zexillian argues that it represents a valuable perspective. He says the greatest engineers must understand both the complex and the simple." 2 months later, the Academy faced an unexpected crisis. A power surge in the main reactor threatened to destabilize the entire facility's energy grid. The advanced safeguards had failed, and the engineering faculty was scrambling for a solution. Victor was in the middle of a different class when the emergency alert sounded. Students were instructed to remain in place while the situation was addressed, but a specific message appeared on Victor's display. "Cadet Owens to Engineering Control, immediately." When Victor arrived, he found Professor Zexillian and several other faculty members huddled around the main control interface. The displays showed cascading failures throughout the power distribution network. "Owens," Zexillian said when he spotted Victor, "we have a situation similar to your exam scenario. A quantum fluctuation is causing phase misalignment in the primary power couplings." Victor quickly assessed the displays. "The standard protocols aren't working? The automated systems are designed to handle normal fluctuations," one of the other professors explained. "This is beyond their parameters, and our attempts to implement more sophisticated solutions are being rejected by the safety systems. We need a simple, physical solution," Zexillian said, the words clearly still strange to him. "Your approach." Victor examined the system diagrams. The Academy's power system was far more complex than anything he had worked with on Earth. But the fundamental problem was surprisingly basic. A power surge had created a feedback loop in the quantum harmonizers. "I need access to the maintenance bay," Victor said, "and I'll need a few specific items." 20 minutes later, Victor was in a maintenance suit, floating in the Academy's central power distribution hub. The space was designed for robotic maintenance, not humanoid access, making the work challenging. Krellner had volunteered to assist, his crystalline form more adaptable to the tight space. "This is what you call duct tape?" Krellner asked, examining the roll of specialized insulation material Victor had brought. "This is the advanced version we use in space," Victor explained. "The principle is the same. It creates a physical barrier and bond that can redirect energy flow." Working quickly, Victor identified the failing components. The quantum harmonizers were vibrating out of phase, creating a cascading failure. The Academy systems were trying to compensate with energy fields, but that was only making the problem worse. "We need to physically stabilize these 3 junction points," Victor explained to Krellner. The tape will create a temporary pathway that bypasses the failing harmonizers while maintaining the quantum coherence. That contradicts standard emergency procedures, Krellner noted, but he was already helping position the materials. Sometimes the simplest solution is the best one, Victor replied as he carefully wrapped the specialized tape around the first junction point. The work was precise and dangerous. One wrong move could accelerate the cascade failure or expose them to lethal levels of radiation. Victor's hands moved with practiced confidence, applying the tape in specific patterns that would create the necessary energy pathways. The fluctuations are decreasing, Professor Zexilian's voice reported through their communication systems. Continue with your procedure, Cadet Owens. After 45 tense minutes, Victor secured the final connection. The tape glowed slightly as it conducted and redirected the quantum energy, creating a stable pathway around the damaged components. Fluctuations have ceased, Zexilian announced, power levels stabilizing across all systems. Victor and Krellner made their way back to engineering control, where they were met with something Victor had never experienced at the Academy: applause. The engineering faculty, typically reserved and formal, were openly acknowledging the success of his unorthodox solution. A temporary fix, Victor emphasized as he removed his maintenance suit. The harmonizers will need proper replacement within a few days. A temporary fix that prevented a catastrophic failure, Zexilian corrected him. The Academy's safety systems estimate we were 17 minutes from a complete power core collapse. The incident marked a turning point in how Victor was perceived at the Academy. No longer just a curiosity or a diplomatic gesture, he had proven the value of human problem-solving in a crisis situation. Professor Zexilian, once his harshest critic, became an unexpected advocate for incorporating human engineering approaches into the curriculum. 6 months later, as Victor prepared to graduate, he received a formal invitation to join the Galactic Engineering Council's Emergency Response Division, the first human ever offered such a position. They were particularly impressed by your ability to implement effective solutions with minimal resources, Zexilian told him when delivering the news. The Council believes that as galactic civilization expands, such skills may become increasingly valuable in frontier regions. On graduation day, Victor stood among his alien classmates, no longer feeling like an outsider. Krellner had become a close friend, and even the initially dismissive students had come to respect his contributions. The graduation ceremony included a traditional presentation where top students demonstrated their most significant academic achievements. When Victor's turn came, he stepped onto the central platform. For my presentation, he began, I would like to demonstrate a principle that has been fundamental to human engineering for centuries: the concept of improvised solutions. He displayed a holographic simulation of increasingly complex engineering problems, each solved with remarkably simple physical interventions rather than elaborate technological solutions. In human history, we often face challenges with limited resources, Victor explained. This necessity forced us to develop approaches that focus on core principles rather than technological sophistication. From the audience, Professor Zexilian watched with his 4 eyes intently focused. Victor could see the professor's expression had changed dramatically from the dismissive alien who had once declared humans incapable of solving advanced engineering problems. The solution that many of you now refer to as the duct tape method is not actually about the tape itself, Victor continued. It's about recognizing that sometimes the most effective approach is not the most complex one. After the ceremony, as students and faculty mingled in the grand hall, Victor found himself approached by a delegation of aliens he didn't recognize, representatives from various engineering corps across the galaxy. Cadet Owens, one of them, addressed him, a tall, insectoid being with iridescent wings. I am Director Trantix of the Deep Space Engineering Corps. We have followed your work with great interest. Thank you, Director, Victor replied, trying to maintain his composure. Your approach to the pulsarian paradox has sparked considerable debate among our senior engineers, Trantix continued. Some initially dismissed it as primitive, but practical applications have proven its merit in emergency scenarios. Another member of the delegation, a gelatinous entity contained within a hovering technological shell, moved forward. We have implemented your methodology in our emergency response protocols across 17 sectors, it said, its voice translated through a small device. Preliminary data suggests a 22% improvement in crisis resolution times. Victor was stunned. He had hoped his work would be taken seriously, but implementation across multiple galactic sectors exceeded his expectations. Professor Zexillian joined the conversation, standing beside Victor with what might have been interpreted as pride. Cadet Owens has consistently demonstrated that different evolutionary paths can lead to complementary problem-solving approaches, he said. His work has prompted me to reconsider many of my own assumptions about technological development. Indeed, Director Trantix agreed, which is why we have come with a proposal. The director explained that the Galactic Engineering Council was establishing a new division focused on developing innovative emergency solutions for frontier regions where advanced technology might not be readily available. They wanted Victor to lead the initiative, working with engineers from various species to create a new approach to crisis management. Your species' history of technological development under resource constraints gives you a perspective that many of our engineers lack, Trantix explained. We believe this perspective will be invaluable as we expand into regions where our standard approaches may not be feasible. Victor accepted the position, recognizing the opportunity to further establish humanity's place in the galactic community. As the reception continued, he found a moment alone with Professor Zexillian. I must confess something, Zexillian said, his voice lower than usual. The Pulsarian Paradox exam was specifically designed to be unsolvable through conventional means. It was a test of creative thinking, not just technical knowledge. You knew a physical solution was possible? Victor asked, surprised. Not precisely, Zexillian replied. But I suspected that a species with your evolutionary history might approach the problem differently. What I did not expect was the elegance of your inelegant solution. So it was a test within a test, Victor said, understanding dawning. The Galactic Exchange Academy has hosted students from over 4,000 species, Zexillian explained. Each brings unique perspectives shaped by their evolutionary path and cultural development. Humans are new to our community, and we needed to understand your cognitive patterns. Victor shook his head, amused rather than offended. And your conclusion? That humans possess a remarkable ability to find direct solutions to complex problems, Zexillian said. Your species lacks our technological sophistication, but you compensate with an adaptability that many advanced civilizations have lost. The day after graduation, Victor began preparing for his new role. As he packed his belongings in his academy quarters, Krellner came to say goodbye before departing for his own assignment. I brought you something, the crystalline being said, presenting a small object. It was a roll of actual Earth duct tape, somehow procured despite the rarity of Earth products in galactic markets. How did you get this? Victor asked, laughing as he examined the familiar silver roll. I have connections, Krellner replied, light refracting through his form in what Victor had learned was his species' equivalent of amusement. I thought you should have a reminder of how you changed Professor Zexillian's perspective on humans. It wasn't just my perspective that changed, Zexillian's voice came from the doorway. The professor entered, carrying a small data crystal. The entire engineering council has taken note of your approach. He handed the crystal to Victor. This contains the official documentation of what is now being called the Owens principle in emergency engineering, the concept that physical intervention can sometimes succeed where energy-based solutions fail. Victor accepted the crystal with a sense of wonder. 3 years ago, he had arrived at the academy feeling like an imposter among the advanced species. Now his name was being attached to an engineering principle that would be taught to future students. Your work has opened new avenues of research, Zexillian continued. Several faculty members are exploring applications of physical stabilization techniques in quantum engineering, a field where such approaches were previously considered too primitive to merit investigation. As Victor prepared to depart for his new assignment, news arrived that Earth had been granted expanded participation in the Galactic Exchange program. The success of the first human student had convinced the admission council to accept 5 more in the coming term. Victor's final act at the academy was to prepare a welcome guide for these future students' advice on navigating both the academic challenges and the cultural differences they would encounter. Remember, he wrote in the conclusion, what others may see as your limitations can become your greatest strengths. Human ingenuity has a place among the stars. On his first day at the Galactic Engineering Council headquarters, Victor was shown to his new office, a space designed for a human occupant, with a small shelf prominently displaying a roll of duct tape encased in a transparent preservation field. A note beside it read, "To remind us that sometimes the simplest solution is the most revolutionary. Welcome, Engineer Owens." Victor smiled as he settled into his new role, ready to show the galaxy what humans could contribute. The journey had begun with an impossible exam and a desperate solution: duct tape holding together a theoretical quantum engine. Now it had led to a position where that same creative approach could help shape the future of galactic engineering. As he reviewed the first crisis scenarios assigned to his division, Victor reflected on how far he had come. Professor Zexillian had been right about one thing. Some problems did have no solution for certain species. But that didn't mean they had no solution at all, just that the right perspective was needed to find it. And sometimes, that perspective included duct tape.